Hello. So here we have a problem from analysis. We're supposed to let a and b be any real numbers, and we're supposed to show that the minimum value between these two, whatever one is smaller, is going to be equal to a plus b minus the absolute value of a minus b over 2. Now, the thing that makes this proof a little tricky is the presence of the absolute value function here. And we're just going to write the definition of the absolute value of a minus b just to kind of have our ducks in a row. It's a piecewise function, and it's going to be equal to a minus b if a minus b is greater than or equal to 0. And conversely, if this value here, a minus b, is strictly less than 0, it's going to be equal to the negation of it. Now, by listing the explicit definition of the absolute value of a minus b, we found ways to remove the absolute value. And how we're going to remove it is going to depend on what a minus b is specifically. So here is a good opportunity to do a proof by cases, depending on either one of these cases we have here. So we'll just start with the first case. Case 1. A minus b is greater than or equal to 0, and equivalently, this means that a is greater than or equal to b, which implies that the value of min ab is going to equal b. So we know that the min of a and b is going to be equal to b. Now it's on us to show that this value here, a plus b minus the absolute value of a minus b over 2, is going to be equal to b. So we'll just write this down. A plus b minus the absolute value of a minus b over 2. Now, we know that a minus b is greater than or equal to 0. And using this definition of the absolute value that we have up here, that means that this absolute value is just going to be equal to a minus b. So we can write this out as a plus b minus a minus b over 2. Now we can distribute this minus across inside the brackets here, and we'll have a plus b minus a, and then negative times negative is positive, so we'll have plus b over 2. And then we see here, a minus a is going to cancel out, and we have 2b over 2, which is just equal to b, because we're dividing these 2's. So we can see that in this first case, the minimum value of a and b is going to be equal to b, and this value here is going to also be equal to b. So under this case, this equality is proven. Now, we got to consider the next case, case 2, where a minus b is strictly less than 0. That implies that a is strictly less than b, and that implies that the minimum value of a and b is going to be equal to a. We're going to do something similar here. We're going to consider this value here, a plus b minus the absolute value of a minus b over 2. This time, it's different though, because as we've noted, a minus b, under this case, is going to be strictly less than 0. So we can go back to our definition of the absolute value here, and we can note that this time, the absolute value is going to be negative a minus b. So we're going to write that out. We're going to have a plus b minus, and then we're going to have a negative a minus b divided by 2. And this is, we're going to distribute this minus sign. So we're going to have a plus b, and then this is just going to become plus a minus b over 2. And then here, we can just write this out. We can just remove the bracket, and we have a plus b plus a minus b over 2. Now here, we have b minus b. So that's going to cancel out, and we're left with 2a over 2. We can just divide that, and we're left with a. So under this case, we've noted that the minimum value of a and b is equal to a. and that this value here, a plus b minus the absolute value of a minus b over 2, is also going to be equal to a. So we've covered both distinct cases here, and we have proven that no matter what, this equality is going to hold. So we are done.